Hey guys, welcome to our webinar. Today we're going to be talking about SageMaker MLOps. Today we have on the call, uh, my name is Pranav Murthy. I'm an AWS Solutions Architect and an AI/ML specialist on the SageMaker team.
Hi, and I'm Paul Hargis. I'm also an AI ML specialist, AWS Solutions Architect, and I will be presenting the second half of the webinar.
Thanks, Paul. So the agenda for today's presentation and demo is going to walk you all through uh, the typical patterns for exploratory data analysis and how you can undertake exploratory data analysis on SageMaker using notebooks on Studio or leveraging processing jobs to process your data at scale. Then we're going to be quickly touching up on model training and model tuning and how to leverage model registry to scale out model deployments within your organization. And Paul's going to be quickly touching up on inference and hosting and how to operationalize your workflow on SageMaker. So in essence, we're going to be walking through different pieces of data science lifecycle. And then Paul's going to, at the end, showcase how they can all be chained together using SageMaker tools. Today, we're going to be talking about exploratory data analysis and how you can do EDA on SageMaker Studio. So today, there are three ways to do EDA on SageMaker. You can use Amazon SageMaker Data Wrangler, which is a fast and visual way to aggregate and prepare your data for machine learning. You can also do exploratory data analysis in situ on Studio notebooks. You can locally prepare your data, leverage that data to train your model, even train your models right on the Studio notebook. Or finally, we can leverage SageMaker processing job to prepare, analyze your data at scale. In today's webinar session, we're going to be focusing on SageMaker Notebook EDA, quickly introducing how we can run exploratory analysis on Studio notebooks, and finally, how you can process the same job at scale using processing jobs. So what is Amazon SageMaker Studio Notebook, and how can you use it to perform EDAs? Within Studio, you get access to notebooks. So think of Studio as a web IDE, and right there within Studio, you have the tooling available, such as SageMaker Experiments, which allows you to log your explorations and visualize those explorations right within Studio. And just like how you would work with any notebooks on your laptop or on any other IDE, it's as easy to work on SageMaker Studio. So moving forward, what is the advantage of running EDA on SageMaker Studio notebooks? There are no wrangling environments. It's as easy as launching a new notebook in under 30 seconds, pinning your notebook to a compute backend, running your EDA, and you can even switch your backend and proceed to train a model, thereby enabling cost reduction when you're doing heterogeneous workflows such as exploration, model training. With Amazon SageMaker processing job, it's a fully managed solution for data processing and model evaluation. SageMaker processing jobs are fully managed, which means that the cluster for distributed processing is managed by Amazon SageMaker in the backend. You don't have to worry about setting up the clusters or tearing them down. You can leverage your own processing scripts to run data processing, or you could bring your own containers into SageMaker to run your processing jobs. So let's quickly jump over to to a demo. So the first demo we're going to be seeing is how to do exploratory data analysis within your notebook. So here I have a few notebooks that I have that are running some code. The first notebook that we're going to walk through is how to do exploratory analysis on the SageMaker notebook. So the way we do is you can create a new notebook. You can choose the container image type that you'd like to run your notebook on. I'm choosing data science kernel. A data science kernel typically contains most popular data science frameworks out there, such as matplotlib, pandas, numpy, etc. So data scientists don't have to spend time preparing containers or installing packages. These are readily available out of the box, and you can just select the backend you'd like. And I'd also like to point out, there are so many images out there that you can choose. If your code has dependencies on, let's say, PyTorch, we do have PyTorch CPU and GPU optimized containers for you to run your code on. So the first step is to choose an image type. In the next step, we choose the kind of instance that we'd like to do our exploratory analysis on. Right now, my data is not that large. I'm going to choose an MLT3 medium instance to do this analysis. So once I select my image and the instance type, my notebook is ready to go. So I'm going to import my dependencies. I have my data set in the root of my project directory. So your SageMaker Studio user profile has an EFS mount attached to it. So you can bring your sample data set onto Studio and use that for analysis, model training, local model training, and all the other tasks. So think of a scenario where you have a small sample data set that you'd like to experiment with. Once you're done with experimentation, maybe you have 1,000,000 rows that you'd like to process. And that's where we'll be leveraging processing jobs, which I'll talk in a while. But yeah, so let's read our data set and see what our data set looks like. So right here, there are a lot of different columns, and we're trying to predict whether a fraud occurred for this data set, for a row in this data set, and what time did the fraud occur. So features are effectively, it's a credit card fraud detection system, and our features are representing a binary classification of 0 meaning no fraud, 1 meaning there is a fraud. So let's analyze the columns within our data set. There are a whole bunch of floating point value columns. We see here that we do have a prediction or our target class called class, which is an int, which means it is most likely a 1 or a 0. Now let's explore our data set. Let's look at our distribution between our yes and no classes or 1 and 0 classes. So we can straight up see that the 0 class, which means the non-fraudulent transaction classes, are overwhelmingly much larger than the 1 class. We probably wouldn't be able to even see it here. So this is not ready for model training. So we're going to have to balance this data. We're going to have to analyze how many of these features are correlated to our predictors, etc., which we can do in the next step. So this one class is too small. We only have 492 one samples, while we have 284,000 zero samples. So then we go in and analyze fraudulent transaction distribution or across the amounts and the number of transactions that have happened. So we can see a whole range of transactions at different amounts, but a lot of them, it just does seem to be a skewed distribution. Now we see percentage of our imbalanced data set. So there's only 0.1% of fraudulent transactions, while there are 99% of non-fraudulent or regular transactions. So before we actually try to train our model, we're going to balance our data set. I'm choosing a 2:1 sampling ratio, where for every 2 non-fraudulent transaction, we have 1 fraudulent transaction within our data set. Now, let's just take a quick peek at our data set. Everything is good. Let's analyze how our features correlate to our target data set. And one thing you might be noticing is I'm using the Plotly chart to visualize my data set. Just like in your current data science environment, you can leverage any visualization tool within Studio to analyze and visualize your data set. You can use, popular frameworks like Seaborn, Matplotlib, Plotly, etc. So, just taking a look at this data set, it looks like our class or our Y column strongly correlates with some of these features, particularly V16 feature has a very strong negative correlation. We do see a very strong positive correlation with V11. So it's a mix of correlated and uncorrelated features. Now we can choose to, in this case, eliminate some of the features. So our model is more tuned or finely tuned to the strong predictors. But for this example, we'll keep um, all our x1 to xn features while we're training the model. Now we go in and we check our distribution across fraudulent and non-fraudulent transactions. So as we thought, it's a 2:1 ratio. And then we summarize our entire analysis and upload our credit card fraudulent transaction data set that we balanced into S3 using Panda's built-in S3 upload feature. So we, just like you'd write it to a local filer, you can reference your S3 path and the data frame will be written into S3. This is fine. We did the analysis. Now we know how we need to take our data set and prep it. How do we do this at scale? And for that, we get into processing jobs. So just like the previous notebook, I'm going to choose an image type, an instance type, and I'm going to walk through this notebook. So for this notebook, I do need to set up some session variables, such as I need to instantiate a new SageMaker session. I need a bucket where I can write the artifacts of my processing job. I need the role information, etc. Now, prior to kicking off a processing job and running the same steps as I did before, I need to upload my data set to S3 so it is accessible to my processing container. So I'm going to go ahead and do that. I'm going to upload my credit card, my unprocessed data set to S3. I'm now going, before I kick off a processing job, let's take a quick look at what the processing script looks like. So in my pre-processing script, it's the exact same procedure as with the exploratory data analysis notebook. So what we're doing here is we have a few imports. We're going to read a few command line arguments that I can control, such as what my training size needs to be, my validation size, and my test size needs to be during the data split. I'm going to provide a random state so I can deterministically repeat this or repeat the process if I need to in the future. I provide which target column I would like to process. And finally, the input path, as I mentioned, is going to, your S3 path is going to be mounted into OPT ML processing input. And if you have multiple folders from that bound point, all of those folders are visible from this path onwards. Your output, you can dump it into OPT ML processing output directory, and SageMaker processing job will take care of uploading that to S3. So you don't have to manage the S3 pull and push yourself. So in my processing job, I split my transactions, I balance my data set, I split it into test train and validation. I write the data set into my local output path, and I log a few parameters. And I'll explain in a quick second what these parameters are, and I complete the job. That's the essence of my pre-processing script. So I'm trying to replicate everything I did on the EDA side inside a script. Now, how do I kick off a new processing job? So I'd say it's pretty simple. I create a new scikit-learn processor. I choose the framework version I'd like. So there are a few different variations, a few different framework versions that are available to our users. You can choose the right one for your use case. You provide the type of instance you'd like, and you control the number of instances that you'd like to run this processing job on. If you'd like to distribute this across n instances, you can definitely do that. You can choose the right instance type and distribute your processing jobs so your processing job scales with the amount of data set you have. And finally, I kick off a new processing job by providing my script as an input. So my script is located here, provide that as an input. I'm going to supply a new unique job name. And finally, I supply processing input, which is the S3 path where I uploaded my data set. Let's do, this is supposed to be V1 of my data. Destination for that data inside the container, and whether it's shared by S3 key. There are other distribution types you can choose from. And my processing output is now going into this path. And inside the container, that output can be found in this path. Now, the arguments that I'm using to control my processing job can be supplied as arguments. So my training size, my validation size, etc., can be controlled here. Now, one more thing you may observe is I'm wrapping this entire run or this entire execution with what is called as an experimental run. So SageMaker has an MLOps experimentation toolkit called SageMaker Experiments, where every experimentation that a data science persona runs can be logged and tracked at scale. So how do you do that? And I'll show you in a quick second where you can find your experiments. So you can log your experiments into Amazon SageMaker Experiments with a run decorator and ensuring that that run decorator, switching back to your processing, pre-processing script, you can create a new session. Inside your session, you can call a load run and just ensure that that load run is wrapped around your execution inside your script. So what does it achieve? When you go into SageMaker Experiments, I've already created an experiment called credit card fraud detection. And inside this, it creates a new pre-processing run. Inside this pre-processing run, you get information about this job, such as what is the ARN for that job, what is the name of the job, when it was created, by whom it was created, or modified by whom and created by which user. And you can take a look at some of the components of the processing job. So for example, where was the input and output path? What was the random state that was used, to target column, test data set size? So everything is logged in here. So you can think how this might be useful for reproducibility. So let's say you do your processing job today, 10 days from now, if you were asked to reproduce the same job without SageMaker experiment tracking, it's really hard. You'd have to take notes or maybe try and remember what the parameters of that job were. But with SageMaker experiments, with a simple decorator wrapped around your execution, you can just go back in time, take a look at your experiment and the parameters, and simply reproduce your experiments. So what have we done until now? We have seen exploratory data analysis inside a notebook, a standalone notebook. If you were trying to replicate that process at scale, we've seen how SageMaker processing jobs can be very useful and how tweaking the instance count and instance type, you can accelerate your processing job with a large amount of backend data set. What's next? What comes after processing? We have flexible model training and tuning at scale. So once you've completed with your pre-processing actions, you now want to be able to train a model using that data set. Now, with Amazon SageMaker, you can leverage SageMaker's built-in algorithms such as K-means, XGBoost, PCA. You just provide your data set, you choose the algorithm that you'd like, and you can kick off model training. allow SageMaker to do the undifferentiated heavy lifting of parallelizing your data set, training it efficiently. You don't have to worry about all of that. Bring your data at the end of your processing job cycle and train a model with SageMaker's one of many built-in algorithms. Now, what if your organization wants to bring in their own algorithms to do this? And you can definitely do that. You can bring your data set, you can bring your custom algorithms as a Python script, and you can leverage SageMaker's supported containers. All of these containers are optimized for CPU, GPU execution. You can select the framework of your choice. You can bring your containers. You can use the dataset at the end of your processing job cycle to train a new model. Lastly, if both of those methods don't work for you, what other option do you have? You can definitely bring your own framework, bring your own data set, and bring your own algorithm in the form of Docker containers and leverage SageMaker training services to train your models at scale. Your training jobs are controlled using SageMaker Studio Notebook. You can kick off training jobs in any of the three methodologies that I just previously described using Studio Notebooks, or you can go into your management console and create a new training job using the UI. How can we train our SageMaker models using data in S3 or the data at the end of our pre-processing cycle? So I have a notebook here that's going to walk you through that. Just like the two previous examples, you can come in and you can choose an image type, you can choose an instance type, and you can get started with the new model training task. But at this stage, oftentimes you may want to use more complex frameworks. So you can definitely choose from our many framework types and versions. And you can even choose GPU instances if you'd like to build your model locally within the notebook. And you can switch out the instance type to, let's say, G4DN, GPU enabled instance, so you can train your model reliably without having to run into out of memory issues or slow training jobs if you're only using a CPU instance. That's a possibility. But now for this example, we're going to be leveraging training jobs. So let's walk through the notebook. So we again initialize some SageMaker sessions, which we'll be using throughout this notebook. The output path from our previous processing jobs are referenced here. My training dataset is found in this path. Validation and test are found in the respective paths. Now, there are three ways or three examples that showcases SageMaker training. So in this example, we're going to be looking at scikit-learn training using decision tree classifier. I've defined my framework and my framework version. One thing you may notice that the framework version I'm using for this example is 0.23, which is okay. Just shows you that you can choose any framework version that you like. In the previous example, I used 1x. In this example, I'm using 0.2x version. So let's choose our framework and framework version. Now we define a new prefix and get a new datetime string so we can customize our training job names. So I can identify them later on. And I'm going to log all of my training job into my experiment so I can visualize outputs from my training job, such as my loss value, my accuracy value, my F1 score, etc. The method that I'm using to train a new model is with the bring in own algorithm, but I'm leveraging SageMaker's sklearn extension to do that. So here I define a new SageMaker scikit-learn extension instance. I have defined an entry point, which is a train.py, which is under scripts, training, train.py. And we also see customers sometimes asking for additional packages on top of what may be defined by SageMaker. And right here, you can choose distributed training or single instance training. for this example, it's just one instance, but you can scale the instance count and allow your code to leverage multiple instances for accelerated training. You can choose your instance type. This is a CPU instance type, but you can swap it for a GPU instance if you'd like, or if your training demands that for, let's say, frameworks like PyTorch and maybe CNN model training. And finally, all of my hyperparameters that govern how my model is generated are all controlled using command line inputs to my train.py, and I can specify them as hyperparameters during the instantiation of my scikit-learn class. Now, you see I've defined model criterion, model depth, min leaf size. If I go into my training script, all of those parameters are uh, argparse arguments to my training job. Now, a few more things that you might observe is during a training job, SageMaker will provide you with environment variables such as training channel, validation channel, and test channel. So the data in S3 is mounted onto your container similar to a processing job, but they're mounted in specific paths. So you can just specify the OS and Baron values for these, and they can be picked up and used throughout your training session. Your model output, your model.dir, you can dump your model right there. So your model will be zipped and available to you for downstream usage. And any artifacts that you generate, maybe images or maybe charts, etc., you can dump them into output directory, and they can then be used for analysis, downstream analysis. But we'll kind of see how SageMaker experiments allows us to do that, and not even use our output directory for this task. And then during the fit operation, I reference my train, validation, and test data paths, and I can kick off a new training job. So this is going to be running in the backend, but let's move on to the next example, which is using first-party XGBoost classifier training. So in a very similar way, I'm going to, using SageMaker's image URI retrieve function, I'm going to check what images are available for the XGBoost framework. So, these were the available versions as of the notebook was prepared, but there might be more if you upgrade your SageMaker Python SDK. So you can come in, I'm choosing my specific framework version of choice. And now I'm going to be calling my XGBoost training as training XGBoost, so I can identify that in my SageMaker experiments. With the built-in algorithm, you don't have to you don't have any code that you need to specify. You just have to ensure that your data set is visible to the algorithm. Just like here, I'm providing this as inputs, and I'm specifying the content type. And I provide my role, instance count, my SageMaker sessions, set the hyperparameters for my training session, and I can kick off a new training task. Also note that the hyperparameters that I set are exactly the same as open source XGBoost hyperparameters. So there's nothing special about the hyperparameters that you find um, with SageMaker's first party algorithms. So this is going to kick off a new training task. So let's go take a look at both of those training tasks. So if I go into experiments, I can see an sklearn job that's currently running, and also the XGBoost job that's currently running. But we actually don't want to watch paint dry. So what we could do is I have a job, an old job that I have that we can take a quick look at. So here's a nice training sklearn using bring your own algorithm. So within my training job, I actually logged values such as final recall, train mean at sample size, the accuracy value or cross validation accuracy value at different sample sizes during train and then test. And those values, which are continuous outputs, will be available as a summary for me. But what if I'm a more visual person. So you can go into your charts. The same logs can be visualized using line chart. So for example, I can choose step, wall time, or relative time. But for this example, I'm going to choose step, and I'm going to log my training mean at sample size values. Now I can say it's mostly flat. The accuracy value for my training job was around 0.97, 0.98, so it hasn't varied a lot, so that's good. Now I can even visualize uh, final accuracy or final F1 score in the form of a bar chart as well. And the last thing is the most common practice is to log confusion matrix for us to analyze at the end of a training session. So SageMaker provides a built-in method to analyze confusion matrix, and you can log it very easily within your training job using run.log confusion matrix API extension. This is good. I can analyze a single run, and I can do some deep dives into the model and maybe leverage um, learnings from a training session to improve my next set of models. But what if I'm running a hyperparameter tuning session? What if I know the parameters, or at least the ranges of parameters that I'd like to train the model on? How is SageMaker Experiments going to help me? So for that, let's just look at a very simple hyperparameter tuning example. I'm replicating the bring your own algorithm example using scikit-learn, the exact same framework version, but I'm going to be altering the hyperparameter values into my training session, and I'm going to kick off 4 training tasks. So all 4 of these training tasks are running in parallel, and you can visualize them either in SageMaker Experiments once they're done, or you can look at the status of these jobs on your SageMaker management console, or you can use API to get the status of your training job. Now, again, we don't want to wait for these jobs to complete. So I'm going to open up experiments. I do have a few jobs that I'd scheduled before this. Let's probably take a look at those. Now, as you can see, with similar naming convention, I have a few training jobs that have completed before this. Now I can go into individual training jobs, take a look at the metric summary table, see how different models are performing one after the other, but that's not efficient, and that's not how people like to perform analysis at scale. So what other alternatives can I suggest? Well, you can actually go in. Let me remove the jobs from this table. What you could do is select a whole bunch of these runs simultaneously, and you can analyze them in a side-by-side manner. So here's the same table overlaid, every job overlaid on top of each other. From this, I can say possibly the first run was the best, which has a depth of 1 and min leaf of 2, which is great. But again, I'm a more of a visual person. What do I do? So I can create a new bar chart, and I can select my final uh, F1 score and see how all of these different models compare against each other. I can also check any loss outputs that I might log during my training session. So I can come in and I can say I want to look at the mean, test accuracy score for given different sample sizes that I logged during my training session. As you can see, all 4 of them look very close to each other. Not a lot to differentiate them, but from this analysis, I can quickly come to the conclusion that possibly the if you look at the naming convention, you could say that one run is better than the other. So possibly the run ending with 4042 is the best. That's great. Now I can go back, take a look at, let's see, here we go. The 4042 run, I can look at where the model is. I can look at the hyperparameters about the job. I can take a look at the artifacts if there were any for the training job. So my 4042 training job was the best. Now, what do I do with that data set? What can I do with that model? Or where is that model that's available? That's at the end of that training cycle. So what you could do is, here's the best training job. I have it already kind of written out. I'm going to attach to that session, and I'm going to take a look at where the model artifact is. So let's copy this here. Okay. Guess I had to redefine and reattach. There we go. So this is our model right here. What can we do next? We can register our models into model registry. A model registry effectively is designed into model package groups and model packages themselves. Model packages are individual model entities, such as the model at the end of your training session, uh, parameters that went into generating the model, the algorithm type, etc. And if you have multiple models generated for a single experiment type, you can group them into model package groups. So in essence, model registry is a collection for your versioned models. So what do we do with the model at the end of a training session? So what we can go ahead and do is first create what is called as a model package group. So model package group in this use case is all the models generated from our credit card fraud detection dataset will go into credit card fraud detection model group. You can have decision tree classifier, XGBoost model, and different kinds of models all sitting under a credit card fraud detection model group. And you can have multiple versions of either XGBoost or decision tree models, and they'll all be automatically versioned. And you can use model package your model package as a central hub for deploying models to an endpoint, controlling whether some of these models are okay for deployment, can be staged for deployment, or is rejected for deployment. So let's go ahead and create a new model package group. I've already created one, so let's go take a look at that. So here I have a model package already generated. So in my model package, I have two versions already registered. Let's walk through the process of registering a new model. So given this is my best training session, I've just attached myself to the best training session. And now the best sessions model can be registered into a model registry by defining a few things about the model. So you can control your model's input and output content type. You can say you can only accept JSON or text CSV, and you can control what types of instances that can be used for inference. So you're setting up guardrails around your model for deployment, and you can set the approval status to either pending, approved, or rejected automatically uh, during registration. You can you can control the description of your model. So I'm going to go ahead and do that. Oops, I guess there is a framework. There we go. It's pending manual approval. My bad. There we go. Our new model is registered. Let's go into model registry. Let's open this up. Here's a new model waiting for manual approval. If I was a product owner for this particular model, based on the description and based on the metrics of the model, I can come in and either reject the model, approve the model, or have further discussions with the data scientist that generated it. So here we have and we can open this up. This new model is now approved and was updated by the data science user, which is me, updated by this persona, and now ready for deployment. For the next set of actions post model registry, I'm going to hand it off to Paul to present the rest.
Yes, so this is Paul, and I'll be picking up from where Pranav left off, which is having built a model and storing it in the model registry. So in the remaining time, we're going to talk about SageMaker's MLOps tooling, which are primarily revolve around pipelines and projects. So as you already know, any project is not complete until you've deployed to a either a real-time endpoint or a batch transform. So SageMaker has both of these capabilities. Today we're going to use a real-time inference endpoint. Okay, so I've got a demo that I'm going to walk you through this, but I wanted to bring in some overview information. So when we're working in the ML lifecycle, most of everything we do is iterative. So that includes building, training, and tuning, running pre-processing, all the things that Pranav just walked you through. So these things happen over and over again. So these tools that we're going to show you next are to help you efficiently achieve those goals. We're going to be able to get models from concept to production. We're going to be able to track artifacts, deploy and manage particular versions of the model, and then automate at scale. SageMaker Pipelines is a purpose-built tool set to do exactly these things. It's going to help you compose and manage ML workflows. You'll be able to track model lineage, replay and rerun workflows so that once you create them and get them working, you can simply schedule them or trigger them manually. We will look at the visual tools available within SageMaker Studio. There's the model registry, which is the central repository of trained models. And we're also going to talk about how you can satisfy full CI/CD support within these tools. So SageMaker pipelines then can be used across the end-to-end ML spectrum. So all of the steps that Pranav just showed you, pre-processing, training, tuning, these can all be codified within a workflow. So we can prepare and transform and train and validate. And so at the end of his presentation, we left off with the model registry, and we need to deploy these things into production to get value from them. So today we're going to use the SDK toolkit in order to create a pipeline, and I will show you both the inputs and the outputs of that. Also within SageMaker Studio, we can visually inspect the pipeline at any stage while it's running. We can look at workflows while they're running or after they're completed. So the typical steps in a workflow include many different types of jobs. So we call these step types. And some of the ones we'll show you today are processing, training, conditionals, register model, and such. So I will show you the code that actually creates each of these steps. And then the pipeline is in charge of executing these steps in order or in the order that we specify. And the conditionals also give you branch points where you can check for a certain condition and take one route or a different route within the workflow. So we will pick up from the model registry that has just been built, and that's where we'll begin our journey. The CI/CD portion of the workflow is handled and constructed by SageMaker projects, which is related to SageMaker pipelines. And projects, that's the first thing we'll do today is create the actual project. Projects exist from a series of templates. SageMaker provides a set of templates out of the box. There's about 7 or 8 of them currently, but you can also download, modify, and upload your own organizational templates. We'll look at this in the demo portion, but a project consists of a series of hierarchical artifacts, and we will walk through those. All right, I'm going to stop this presentation, and I'm going to jump over to SageMaker Studio. Actually, before we look at Studio, I want to show you that the examples I'm showing you today are freely available under GitHub, and this repository is the one I'm using today. So we'll provide this in the artifacts with the webinar. So I've just launched, from the homepage, I've pulled in a set of project templates, and these are available within what we call the service catalog. And if I want to search for them, I can search here, and I can see that the service catalog is a version set of templates, and those are the ones we're going to use today. So let's go ahead and get started. So I've got a couple of notebooks up and running from the repository that I showed you. First thing we're going to do is create a project. And we can do this in two ways. We can create it programmatically using the SDK, which is what I'm going to do today, or we can use the visual tools within SageMaker Studio to create. So this notebook has already created a project, so I'm just going to briefly run through the code on how to do this. You see that we pick up data from the service catalog. We choose a provisioned artifact. We then locate a template. Next thing we do is we programmatically do a create project. So this actually created the project for me, and we see the outputs of that creation here. We wait for it to complete, and now we have a project. So the next few screenshots here within the notebook show you how you would do this within Studio. And so we start from a particular template. We select that template and tell it to create the project, and we wait for it to complete, and then we're ready to go. So now, this shows the actions that we just took. So whether we do this programmatically or through the Studio visual interface, the same steps are occurring. So we're importing from the service catalog. We're going to be creating a pipeline in just a second, and the project is also going to create some seed code for us that it's going to exist in code build and code commit. And then we're going to tie it together with code pipeline. I'll show you more of these details as we go. So this project was already created. If I hop over, so in the Studio UI, most times you're seeing what is this file browser, and this left-hand panel is the navigation panel. So I'm sitting here in the file browser, but if I come up to the home button, this is where all of the components, the SageMaker components, can be accessed. So we could get access to feature store, data wrangler, experiments, pipelines from right here. What I did was I opened up the model registry. I opened up the projects screen, which is right here. So I'm going to hop over there and look. And so you see that there's a fairly new project here that was created today. And so this was the project that got created. And so if we open that up, we see that there's a hierarchy of artifacts that are part of this project. The first thing you'll note is that there is a repository. We can clone this, which would bring it down from the remote to our local file system. And so that's an option that we have if we wanted to edit that code. We also have the SageMaker project also created a pipeline for us, so we can open that pipeline and look at it. You can optionally create an experiment, and the end goal, as Pranav showed us at the end of the training and tuning, is that you have a model group to view. So this notebook essentially created what we call a project, and then we can interrogate that project and get information about it right here. The next notebook that we're going to pull from is actually showing the model deployment and showing the deployment phase of the pipeline. I'm going to Yeah, so this is we've already created the project, and now we're ready to create the pipeline. The, um, the actual creation of the pipeline is here in this notebook, and so I'm going to scroll down to the creation of that. Okay, so here's a simple pipeline showing training, build, train, and tune. So um, what we have to do is we have to create these objects one by one. So we instantiate them just like we would if we were executing this training live. We create the training object, and then we do a trainer an estimator.fit, but we encode that as a training step, and this is part of pipelines. So this is one of the steps in the pipeline. We will also do an evaluation step. We created a pre-processing step as well. I'll show you that in a second. So we're instantiating these objects, and then the last thing we do is encode them into a particular step, depending on the type of step that we are executing. We then create a model here. So we instantiate the model and get some metrics, and then we again instantiate it as one of the types of steps. This is called a model step. I mentioned that we could do conditionals, and so it's convenient sometimes if a condition fails and fails to give you the proper result, you can encode a fail step, and that can be used to alert your team of MLOps people that a particular pipeline has failed. Here's the encoding of the condition step right here. So we embed some condition that's based on the metrics that have been produced. So in this particular instance, we are going to compare the AUC score, which has been produced by the training run. Now, the next step is to actually create the pipeline. So we've talked about pipelines and what they do. Now we're going to show you that we are actually creating the pipeline using the SDK. So this code actually creates a pipeline. We give it a name, and we pass in a series of parameters that control the execution of it. And then the most interesting part is that we wire together the steps in a particular order, and we mention those in a list here. So these become the steps of the pipeline. So what we see is, SageMaker pipelines will render a diagram for you that shows you exactly what your pipeline is doing. And so this is an example. This is from the GitLab repository. This is the example that we're using. Now, to execute the pipeline after it's been created, we have to do an upsert, which uploads it to SageMaker. And at that point, we can list the pipeline definition. And I just wanted to show you that real quickly. I pulled the pipeline definition out so that we know what's going on. And this is actually the real pipeline that I just created. And you see how it encodes all of the information that we're interested in. It has a section on parameters. And then here come the steps, and there's a processing step, if you recall. There's training steps, there's eval steps, here's the training step. And so the pipeline that we've created is just a JSON file that includes and encodes all of the steps, the arguments, the parameters, and the conditionals. So that's what we just created. So we're able to download that here. Now, to actually execute the pipeline, when we call on this, we do pipeline.start, and we provide the instance types and counts that we want to use in order to run that pipeline. We can wait for it if we choose, and then we can list the steps and download that. So I opened up, let's go look at a pipeline. So now we can get to this pipeline from a couple of different ways. We can get to it from here. So here we are in our project. And so I've opened up this pipeline. This is one of the artifacts that got created by the project. So I open this up. You see I've actually executed it twice since I created it. And so we can look at one of these executions. So we did right now we can we can look at the settings and the parameters that were used in order to, when we created this pipeline, but we can also open up an actual specific instance. So here is an instance of an execution of the pipeline. Again, we can access settings and parameters, but we can also drill in and see particular information about this particular execution. So we can see all of the input parameters for the training job, for example. We can see if it had any outputs. So in this case, we have the AUC numbers. We can also go and visit the logs of the training job if we want. So those links are provided as well. So we can scroll around and evaluate each of these steps and look at and get more information about each of them. And the last thing that we do is we register the model. So if we come over here to the model registry, then this model package group will show up here, and we can open one of those. And we see that some versions of this model were pending, but others were approved. So I wanted to show you quickly where that was done. Hold on. Yeah, so you can do that in the visual UI, or you can do it programmatically. So this is how you would update a model package and approve it using some code. But you could also come into here, and let's open this up, and we can also, so we can see several things here. First of all, we can see all of its various lineage, all of the changes in status that occurred to this model over time. So when I created this, I first did I put it in a state of pending manual approval. And what that allows is your MLOps team to come in and do some validation, do some quality check before pushing this into production. Then I either manually or using the API, I approve that model, and then you can see that it's gone through a series of deployments. So this particular model was deployed to staging. So we have these tags out here indicating, which piece of infrastructure we were deployed onto. We deployed it to staging a couple of times. Presumably we validated things there, and then we pushed it into prod. So we have this indicator here that we pushed this model into prod. You can also, if I maybe make some more screen space here, you can also update the status directly right here using the UI. So if you wanted to revert to rejected or promote a model to approved, you can do this with the Studio UI. So that shows essentially end-to-end. Last thing I will show you is the pipeline itself. So we did, we show here a pipeline. Remember, so now we're talking about code pipeline instead of SageMaker pipeline, but this was one of the things that was created by the project. And so what we see here is a full execution of the end-to-end. We start with source code. So perhaps this was triggered by a particular code commit. We made some changes to the source. That led to a build. We used code build to create this. And then next thing we do is deploy to staging. So this is where your MLOps team would come in and they'd say, well, we've deployed to staging, but we need to do some validation. And we get the indicator right here that it's waiting for approval. So what I can do is I can come in here and I can say, maybe give my name and say approved for push to production. I can annotate that, and then I hit the approve button right here. So what that does is you see that the approved deployment step was just indicated. And so what that will do is enable this to deploy to our prod infrastructure. And so that will be going on right now. So if we were to look over here at endpoints, we should, if we wait a few minutes, we should see that they will start to deploy this. But here's some from the previous run. The staging endpoint is up and running, and the prod endpoint is up and running. And then as we can interrogate more information about this particular endpoint, like if we had data capture enabled. We can see statistics from the endpoint, the live monitoring of the endpoint, etc. So that so that concludes our walkthrough of both SageMaker projects, SageMaker pipelines, the lineage tools that go with them, and these are the tools that your MLOps team can use within SageMaker to build, manage, and monitor your models from end to end. So thanks for your time today. Look for the artifacts, and thanks for attending.